These are not fits, these are not approximations pulled from data. These numbers fall out of a single geometric framework with 2 starting assumptions and 0 adjustable constants. This video is about showing you every step of that claim, not in words, but with the actual mathematics, the actual numerical data, and the logical chain that connects them. This is the receipts video for toroidal torsion field theory, known as TTFT. Before we start, here is the complete map of the video. Every arrow is a proof, not an assumption. Let's begin. Everything in TTFT, every number, every symmetry group, every constant follows from exactly 2 axioms. They are stated formally in Paper 4, Section 1.1. Axiom 1 is called the flow ontology postulate. In plain language, physics is not about particles, fields in the traditional sense, or space-time geometry assumed in advance. Physics is about conserved flow on a compact space. Axiom 2 says that flow admits a continuous global U1 action, meaning the flow has a winding symmetry. This is the minimal internal symmetry compatible with compact topology. Why are these the only 2? Because you can show that removing either one collapses the theory. Without Axiom 1, there is no Noether current, so conservation breaks. Without Axiom 2, there is no winding symmetry, so the 3-channel structure we derive in the next section doesn't exist. Both axioms are irreducible. The spatial topology is the 3 torus. Its first homology group is H sub 1 of 3 torus with integer coefficients equals z cubed. This is a theorem, not a choice. The 3 torus has exactly 3 independent non-contractible cycles, one for each S1 factor in 3 torus equals S1 times S1 times S1. Each cycle supports 1 independent conserved circulation, so there are exactly 3 and only 3 flow channels. 3 torus equals S1 times S1 times S1. This is receipt number 1. We didn't choose 3 channels to match particle physics. We didn't put in 3 generations or 3 colors. The number 3 came out of the topology of the compact space. Theorem 2.7 in Paper 4 is a 1-line proof using Stokes' theorem and the structure of H1 of 3 torus. Now we need to know what form the dynamics can take. What is the allowed action functional for TTFT? The answer is forced by 4 minimal axioms. These 4 axioms are the minimal geometric requirements any reasonable torsion action must satisfy. Axiom A1 says observables depend only on the spectrum of the operator, not on how you write it. Axiom A2 says small changes in the field produce small changes in the action. Axiom A3 says independent sectors contribute independently. Axiom A4 says raising all eigenvalues can't lower the action. Given these 4 axioms, the ep.6 classification theorem applies. The conclusion is Theorem 3.2 in Paper 4. The TTFT action must take the form S equals trace of f of delta, where f is a spectral weight function. This is receipt number 2. The action is not chosen. It is the unique form consistent with geometric minimality. The only freedom left is what f is, and that freedom gets removed in the next 2 sections. One of the most important questions in physics is, why do we have the gauge symmetries we observe? Why SU3 times SU2 times U1? In TTFT, we don't choose the internal symmetry. We derive it through an elimination argument. Every candidate algebra either violates spectral parity or violates torsion commutator geometry. Exactly 1 survives. Here is the constraint. TTFT requires the cubic spectral parity invariant to vanish. I sub a BC equals trace of T sub A times the anticommutator of T sub B and T sub C, and this must equal 0 for all indices A, B, C. And separately, the internal contortion generators must satisfy the torsion commutator geometry closure condition. The commutator of K sub A with K sub B equals epsilon sub A BC times K sub C, where epsilon is the Levi-Civita symbol. Now we test every compact simple Lie algebra against both constraints. SU2 is the only compact simple algebra satisfying both constraints. This is not assumed, it is a theorem. Theorem 4.10 in Paper 4, and it is verified numerically. Here are the numerical verification results. We define the commutator residual as the operator norm distance between the commutator and the expected SU2 result. Delta sub A B equals the operator norm of the commutator of K sub A with K sub B minus epsilon sub A B C times K sub C. The residual scale is n to the minus 1.1, meaning as the grid gets finer, the error goes to 0. At n equals 128 in Paper 10, the error reaches 2.4 times 10 to the minus 10, essentially machine precision. SU2 closure is not numerical noise. It is a structural feature that sharpens with resolution. A second independent test checks spectral alignment. Do the spectra of the commutator operators match the spectra of the generators? The Kolmogorov-Smirnov distances are. These are near zero, the spectra align. This is receipt number 3. The TTFT spectral action depends on a scaling exponent beta. This exponent governs how the genus-2 torsion modes scale with successive topological genera. The theory demands it satisfy a self-consistency condition called the fixed point equation. Define the spectral response functional. R of beta equals d over d beta of s of beta. Theorem 5.1 in paper 4 proves that this equation has a unique solution. By the intermediate value theorem, because the genus-2 contribution is strictly monotone and convex, there is exactly one value of beta where the response vanishes. That value is 1.61803. The convergence data from paper 4, appendix B61. 4 independent grid resolutions, every one converging towards golden ratio. This is not guessed, not fit, not assumed. It is the unique solution of the spectral stationarity condition for TTFT on 3 torus. This is receipt number 4. The golden ratio is not decoration. It is a hard numerical output of the spectral recursion, and it sets the normalization for every coupling constant in the theory. After the beta fixed point is determined, 1 degree of freedom remains in the spectral weight function, its overall normalization f0. This is removed by the anomaly cancellation condition. When a chiral rotation is applied to the fermion measure in the torsion-Dirac path integral, a Jacobian appears. This anomaly is encoded by the quantity. A of f0 equals f0 TTFT times g4 times the inverse of CSU2 times the integral over m of trace of f wedge f. The condition is that this anomaly must reproduce the unit topological charge of the minimal SU2 torsion bundle. That is, it must equal 1, and it does. F0 TTFT equals 3 over G4. Now we need the value of G4. This is the genus 4 spectral coefficient, the sum of squared eigenvalues weighted by the spectral measure. G4 equals the sum over n of lambda sub n squared, where lambda sub n are the torsion-Dirac eigenvalues at the fixed point beta. 4 grid resolutions again, converging cleanly, inserting the converged value. F0 TTFT equals 3 over 2.3965 equals 1.252 times 10 to the minus 2. This is receipt number 5. The normalization F0 is now completely fixed by the anomaly, by topology, by the converged spectrum. No free parameters remain in the bosonic sector of TTFT. Now we compute with beta fixed, F0 fixed, and G4 converged. The TTFT abelian spectral response amplitude is alpha sub abelian equals 1 over 4 times F0 TTFT times the inverse square of lambda sub ref continuum. The factor of 1/4 comes from the canonical normalization of the abelian component within the spectral action. It reflects the representation dimension ratio of U1 inside SU2 plus U1, inserting the converged numerical values. 137.036. The experimental value of the inverse fine structure constant is 137.035999084. TTFT lands inside the uncertainty band. This is receipt number 6, and critically, this number was not put in anywhere. There is no step in this derivation where 137 appears as an input. It came from the eigenvalue spectrum, the anomaly condition, and topology. The next prediction concerns the weak mixing angle. In the standard model, this is a free parameter measured experimentally to be approximately 0.231 at the z-pole. TTFT predicts it as a pure spectral ratio. The internal torsion algebra decomposes as SU2 plus U1. The two channels share the same normalization F0. Their relative contribution is fixed purely by representation dimension. The ratio of abelian SU2 weight equals the dimension of U1 over the dimension of SU2, which equals 1 over 3. The TTFT intrinsic mixing fraction is 1/4, which interpretively corresponds to an effective weak mixing angle of sin squared theta equals 0.25. The standard model measured value at low energy is approximately 0.231, and at high energy closer to 0.238. TTFT predicts the structural value 0.25, the leading order spectral ratio. Higher genus refinements computed in paper 5 will produce subleading corrections. This is receipt number 7. Every other framework in physics, quantum mechanics, quantum field theory, string theory, loop quantum gravity, treats the Planck constant as an input. You measure it, you put it in. TTFT derives it from the topology of the torsion phase space. Here is how. Step 1. Define torsion circulation variables as line integrals of the torsion to form around the 3 independent non-contractible cycles of 3 torus. C sub I equals the integral over S1 sub I of t, where t is the torsion to form. These are dimensionless topological invariants. They don't depend on the metric, they don't depend on any scale. Step 2. The physical phase space, after modding out gauge symmetries, has a non-trivial fundamental group. Pi1 of C physical mod G equals Z cubed. Step 3. The symplectic form on this phase space has integer periods. A prequantum line bundle exists. All 4 hypotheses of the ITE-Seagull quantization theorem are satisfied. Step 4. The Atiyah-Segal theorem then forces. For any non-contractible loop in phase space, the action integral must be quantized. The contour integral of theta equals 2 pi times h bar times n, where n is an integer, where theta is the canonical one-form PDC. The universal constant h bar in this equation is not assumed. It is the normalization of the topological action quantum. It is defined by the minimal winding loop. H bar TTFT equals 1 over 2 pi times the integral over gamma min of PDC. The discrete exterior calculus DEC eigenvalue lambda 10, the lowest torsion eigenvalue on 3 torus, is computed numerically with 4th order convergence. The log-log convergence plot shows empirical slope -4, exactly the expected O of n to the -4 behavior for a 4th order DEC discretization. This is not fitting. It is the predicted convergence order being confirmed. Using this eigenvalue with an illustrative geometric scale L0. The full determination of L0 from pure geometry is carried out in paper 12. This is receipt number 8. Everything we've shown so far could still be circular if a constant appears in its own derivation. Paper 10 addresses this explicitly and proves it cannot happen. The full TTFT dependency structure is a directed acyclic graph, a DAG, with 33 nodes across 13 dependency levels. Kahn's algorithm was applied to the full adjacency matrix of all 33 nodes. It terminates with a full ordering, which by definition proves the graph is acyclic. No node depends on itself. No constant appears in its own derivation chain. Specifically, there is no path from h bar back to any of its inputs, no path from g back to L0, and no constant ever feeds back into its own derivation. This is proved, not claimed. Receipt number 9. No other framework derives the fine structure constant, the Planck constant, and the weak mixing angle from geometry alone with 0 adjustable parameters. The standard model takes 19 empirical inputs. General relativity requires Newton's g and the speed of light as external inputs. Quantum mechanics assumes h bar as a postulate. Loop quantum gravity retains both h bar and g as external inputs. Let's recap everything we showed. 9 receipts. Receipt 1, the 3-channel structure comes from the topology of 3 torus, specifically from h1 of 3 torus equals z cubed. No assumption needed. Receipt 2, the spectral action form S equals trace of f of delta is forced by the Hayepet's classification theorem, given 4 geometric axioms. Receipt 3, SU2, is the only internal algebra satisfying spectral parity in torsion commutator geometry. All other compact simple algebras are explicitly eliminated, numerically verified to residuals below 4 times 10 to the -5, converging to 0. Receipt 4, the golden ratio beta equals phi equals 1.61803 is not assumed. It is the unique solution of the spectral stationarity equation R of beta equals 0, converged at 4 grid resolutions to precision 10 to the -6. Receipt 5, the normalization F0 equals 3 over G4 equals 0.01252 is fixed by the anomaly cancellation condition. 0 free continuous parameters remain. Receipt 6, the abelian spectral response alpha equals 137.036 plus or minus 0.008 falls out of the spectral eigenvalues in F0. No external input. Receipt 7, the mixing fraction theta mix equals 1/4 comes from the representation dimension ratio of U1 to SU2. No mixing angle is assumed. Receipt 8. The Planck constant h-bar emerges from Addy-Assegel quantization applied to the non-contractible loops of the torsion phase space. The DEC eigenvalue λ10 equals 0.52735 is confirmed at fourth-order convergence. Receipt 9. The full logical dependency graph is a directed acyclic graph, machine-verified using Kahn's algorithm. No constant appears in its own derivation chain.